assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this example, we're dealing with an electric generator, which is really just a bunch of coils of wire spinning in a uniform magnetic field, like I've drawn to the left here. And what we want to know is, given all these parameters of this generator's construction, so that is that it has 241 coils, spins at a speed of 79.1 radians per second, the strength of the field is 0.17 Tesla, and the maximum induced EMF we get is 75 volts. We want to figure out what the side length of one of our loops would have to be in order for us to get this maximum EMF right here. So we're assuming that this thing is square. So if we looked at it from the side view, it's square. Okay. So the first thing we need to recall is what the induced EMF is going to be for a spinning loop like this in a uniform magnetic field. And that's going to be given by E equals N times A times B times omega times the sine of omega t. So this will tell you the induced EMF in our AC generator at any given point in time t. Now, we want to talk about things in terms of the maximum EMF here, since that's what we were given. So to write this equation down as its maximized version, we're just going to realize that E here will be maximized when the sine of omega t is equal to 1. So the value really oscillates like this in time. And whenever we're at those peaks up here is where the sine is maximized. So E maximum, or E naught, is equal to N ABW. So now, this equation has a bunch of things we know in it, right? E naught, N, B, and W. But A is our unknown. Now, we actually want to solve for the length of a side of our loop, not the total area. But the total area and the side length are going to be related just because it's a square, right? So the area of a square is just equal to the side length squared. So if we plug that in, we'll have E naught equals NL squared times B times omega. And now we can just solve this equation for L and call it a day. So we'll divide both sides of this equation by N, B, and omega. A bunch of stuff will cancel out. And we will have L squared equals E naught divided by N times B times omega. Now we just have to take the square root of both sides, and we'll have that L is equal to the square root of E naught divided by N times B times omega. Okay. So now, all we have to do is just plug in our values, since they're all in standardized units, I believe. Yep, looks good. So we can just plug all of those values in, and if we do that, we'll get that the length comes out to be 0.15 meters. So we just determined what the length of one side of our square coil needs to be in our generator here in order to produce a maximum induced EMF of 75 volts, given these other parameters of the construction here.